Can you hear me? Okay, we will start.
Yes.
Yes, ma'am.
Okay, thank you. Okay, first I just want to welcome everyone to our first session of our mathematical foundation course. Are you ready to help me to understand with you all the problems about mathematical? Okay, I'm very happy to have you today. Okay, I just want you to be with me. I hope this course will help you to build strong mathematical foundation and feel more confident when solving different types of questions. All I want from you just to help me to ask any questions that you don't know. Okay, don't be afraid. Just answer and ask and make mistakes and share your ideas. It's okay. It's okay for me. And about me, I'm Noha. Okay, I'm mathematical teacher from I guess 7 years. Okay, I graduated from engineering college, and it was very good for me. And this course is designed only to strengthen your mathematical foundation step by step. And we will continue throughout this course according to the schedule posted in the group. If you are following my group, I guess all of you are following my group. I get a schedule and it has all our course about the types and about the names of lessons and the schedule of time, all of that. Okay. I just wanted to make sure that you always check the group for session dates and times, topics we will cover, and projects and assignments, and any important announcement. Okay? Okay. So, are you ready to start our session? Our session today is about sets. What about the set? We're going to talk about sets first, and another time. Anyone, feel free to talk in Arabic or in English. It's okay for me. I just want you to understand. And if you don't understand anything that I talk to you in English, it's okay to tell me that, repeat it in Arabic. It's okay. I don't mind. All I want is just to know that you understood and you don't have any problem. Don't let me go without you understanding all the topics and all the points that I will check with you today. Okay? About the set. What is a set? Any set that I can talk to you. We are set today. What about our set? Our set contains of Noha and maybe Asir, I guess. Right? Iyad, Kenzi, Malak, Muhammad, and another male will join us now. Okay? So all of us today is our set. Okay. So what is a set? Set is a collection of well-defined objects. Okay? Called elements. I hope you record our points, and if you don't want to record it as written, it's okay, because I will send for you a note for our session, and of course I will send for you questions, and I just want you to know something. All the questions that I will send to you is coming from past papers questions. It's okay. Because of that, I just want you to be, after finishing all of our lessons, I will be sure that you faced all the problems that you can take it in your exam. Because of that, all my students, after we finish every question or every lesson, I send for you past papers questions about this topic. Okay? So a set is a collection of well-defined objects called elements. I can't say for anything it's a set if I don't know the elements of it. So it must be defined. Okay? We usually name sets using capital letters. Okay? Example like what? If I say A, maybe A equal what? Equal to 4, 6, 8. Okay, let's see here. What's A? A is the name of the set. Sorry, name of set. Okay, what about 2 are 4, 6, 8? They are elements. All of them are elements. Any problem in that? No. Okay, let's talk about the types of the sets. What are our sets? Do you remember? From the first time that we start to talk about math and about sets of math, we take some sets, and it's very important. There are several important types of sets that you need to know. First of it, if I have in, I guess, KG1, first numbers that you take is what? Is 1, 2, 3, 4, okay? And you can count. Because of that, I call it what? I call it counting. Counting set. Okay, after some times, I said that what? These numbers that can be counted, I can call it natural number. Natural number. This counting set is natural set. Do you remember the name of that? Natural set. Okay, so what's a natural set? Natural set are the counting number, which are 1, 2, 3, 4, 5, 6, and it doesn't end, of course. Okay? So if I said that, if I ask you about 1 million, do you know that 1 million is belong to natural? Yeah, Kenzie? Any problem? Do you want to ask any question?
Yes. Is the name can the pen be without name label?
Okay. So here, if I said that 1 million, 1 million, can it be belonged to natural number? Yeah, of course. Any number can be belonged to natural number, but some numbers can't be. What is the numbers that can't be? That's the numbers that can't be counted. How can I do that? If I wanted to count you, I would say,
Decimal number.
sorry?
Is it decimal numbers?
Decimal number? Maybe decimal number, yeah, because it's not. About decimal number, it's not what? Decimal numbers like that,
It's not
right?
a natural number.
Some kind of that.
And decimal numbers are not natural numbers.
Okay, you said that it's not decimal number, it's not natural number. Decimal number is some kind of that, right? Which is fraction,
Yeah.
right? Do you know that decimal number is belonging to fractions? It can be the name of the fraction, right? Or not? Because it can be converted in 1 second. This 0.01 can be 1 over 100 or 1000? No, 100, because I have only 2 digits on the right of the decimal point, right? But I just want to ask you about something. Decimal number is not automatically natural number. Why? Because it depends on the value. What does it mean? Here is 0.01, it's 1 over 100, which is fraction, right? Right? If I put this 1 here, and this is decimal point here, and 0, 0, it means what? It means its value is already 1. So it's natural. So one kind of decimal number here, it belongs to natural. But if I want to put 0.5, is it natural? No, it's not natural. So natural number, they don't have decimal ports. Can't have decimal ports like that. Okay? So because of that, I told you about the fraction. Why? Because if I have 10 over 5, this is a fraction, right? But if I wanted to ask you, is it can be decimal natural number or not, you will say no, I can't say for that. I just have to make what? I have to get the value. If the value if I get it without decimal parts, so it's natural. If it was with decimal parts, it can't be natural. Okay, you will say 10 over 5, it's gonna be 2. 2 is natural number. Why it's natural number? Because it don't have any decimal parts. It's not 2.1, 2.3, 2.5. Did you get it? Did you understand it or not? Hello?
Yes, ma'am.
Sorry?
Yes, ma'am, I understand it.
Okay, Jerry. So here this is about natural number, and this is one part of the sets. Okay. Now, after natural number, if I want to say any other one, what about 0? You said 1, 2, 3, 4, 5, 6. What about 0? If I said 0, 0, 1, 2, 3 here, now I get to what? 0 is a whole number, okay? So here, if I added 0 to my natural number, I will convert it into what? I will convert it into, who can tell me? Maybe whole number? Right? Right or not? It's whole number, 0 is whole, right? So,
Done.
0 and all positive integers. What about the integers here? I said the natural, and we get out the natural, and we said that we have whole number which has included with 0 and all positive integers. So we are in what? We are in whole number, okay? So can be set with whole number. Now what about the integers? The integers here is between what? It's between 0 here in the middle, and here is 1, 2, 3, and here is -1, -2, and we have also some numbers here. So we are going to make what? We are going to make a set with 0 and positive and negative. Of course, 0 is not negative or positive, so it's integers. Do you have any problem with that? That integers includes negative and 0 and positive numbers? But we have one problem. What is the problem here? We can't make fractions in the integers. Integers can't have any fraction, any fraction or decimal. So if I wanted to say half includes or belong to integer? No, it can't be belong to integers, okay? So how can I put these integers? How can I put this 1/2? How can I put any decimal number? So I get another set which called rational number. What is the rational number? Rational number can be written in the form of P over Q, whereas P and Q are integers. So now I can take any whole number? Yeah. Why? Because all the whole number has denominator is 1. If I said 8, yeah, it's 8/1. So it can be rational, right? And of course, if I have 0.5, because it's going to be 5/10. And if I have 0.25, it's okay. And if I have 8/7, it's okay. All of that are rational. Any problem with that?
Right.
Okay. What about the irrational? Irrational number can't be written as a fraction of two integers. How can I do that? Their decimal exponents, it can be forever without a repeating pattern. So gonna be if I have root of 2, it's irrational. And it's a secret between us. The irrational number coming from any number that doesn't have completely root. If I have here 2, if I have 7, if I have 3, all of that, if I put it below the root, it's gonna be what? It's gonna be irrational number. So if I said root 2, square root of 2, it's gonna be irrational. So any number that I can't put it on the shape of the fraction, it will be irrational. Irrational. Any problem in that? Then finally, some kind of thing told me, how can I put all of these sets in one set? They will be the king here. What is the king here? It's a real number. Are you ready for the king? Real number. What is the real number? The real number, it is a set that includes both rational and irrational. Okay, so if I want to say here about the real number, it includes what? Who can tell me? Rational?
Rational and irrational numbers.
And irrational. Let's make any graph like that. If I say that I have here circle which has counting, and this counting, it's a part of natural, and this natural is a part of integer, and this integer is a part of rational, right? What about the irrational? It's out. Irrational is out. And what about all of that? It can be the king, which is real number. Understand what I mean? Is it okay? Okay. Now about the set. If I say some kind of set like that, as we said first, 2, 4, 6, this set is what is ended. The set has limited number of elements is called infinite set because it's end. Okay? It just has 4 or 3 elements. So if I have, it's not coming out any numbers. It's coming of you 1, 2, 3, 4, and it will continue. So I'm going to be what? So I'm going to be infinite set because it will continue forever. So it's called infinite set. Any problem in that? What about the set that's coming for that? Who can tell me what does it mean? What does this sign mean? Or 2 brackets like that and there is empty. Phi. What about phi? Phi is empty set, right?
Right.
So it's empty or null. It can be called empty or null set, which is phi. Okay? Because it has no elements in it. Very good. Now, if I wanted to make for you an equal set, does it make any difference about rearranging the numbers? So if I have 2, I don't know what's the problem with the pen. Bismillah. 2, 4, 6. Okay, anyone is following, is representing